Welcome to This Explainer. Today, we're unpacking the absolutely fascinating paradox of the Concorde. I mean, think about it. This was a machine that flew right at the edge of space, crossed oceans in just a fraction of the normal time, and totally pushed the boundaries of human achievement. Yet, it failed spectacularly as a business. So today, we're going to look at that massive gap between what's technologically possible and what's actually economically viable.
Okay, let's dive into this. What happens when a project becomes just too important to fail? This is the fundamental psychological trap right at the heart of our explainer today. You see, when a project reaches a certain massive scale, a really dangerous shift happens. The goal stops being just about solving a problem, and it starts being about justifying the existence of the project itself. And this creates what we call the sunk cost trap. It's a vicious cycle, really. Governments pour in massive amounts of money, and because the funding is there, engineers work literally around the clock to solve the impossible. Then, partner companies come in and make these enormous infrastructural investments. Finally, because of all this highly visible effort, the public just expects a miracle. Slowly, the whole thing becomes so incredibly expensive and high profile that admitting failure simply feels impossible to everyone involved. They are totally locked in.
Part 1. Too big to fail. The anatomy of a flawed miracle. Part 2. The supersonic dream. Engineering the impossible. So, picture the 1960s. Jet aircraft had already totally transformed commercial travel. We were flying faster and farther than ever before. But engineers, backed by Britain and France, started asking a pretty obvious question. If jet aircraft could fly at subsonic speeds, why couldn't passenger planes fly faster than sound? Now, the military had already demonstrated that supersonic flight was absolutely possible. But creating a civilian application? Building a plane that could safely and comfortably transport everyday passengers at those insane speeds, that created enormous, totally unprecedented problems. And this brilliantly illustrates the staggering scale of those engineering hurdles. I mean, they had to solve problems that had literally never been solved for commercial aviation. First off, the aircraft required a completely novel, ultra-slender aerodynamic design. The wings had to generate lift efficiently at both low speeds and supersonic speeds. Then, they had to invent this crazy droop nose feature, because the extreme angle of the plane meant pilots couldn't even see the runway during landing. Plus, they needed massive thrust and the ability to withstand surface temperatures so hot that the friction literally caused the plane's metal frame to stretch several inches mid-flight. Just wild. But in 1976, all that engineering paid off in a truly spectacular way. The result totally changed the world. 3.5 hours. Wealthy travelers, business executives, celebrities, they could now cross the Atlantic from London to New York in the time it takes to watch a long movie. Concorde was selling something no conventional airliner could match, the ultimate luxury of time. Let's move to and see how this builds into part 3, the economics of speed. The spreadsheets defeat the machine. Because while the engineering was an absolute triumph, the world was changing rapidly around the Concorde. And the spreadsheets, well, they were telling a very different story. Airlines were forced to ask a brutal, ultimately fatal question. Who would actually pay enough money to make supersonic travel profitable? This is the really painful lesson of the Concorde. Being able to build something incredibly advanced does not necessarily mean the world can afford to use it. To understand the economic failure, we just have to look at the operating reality. Concorde boasted Mach 2 plus speeds and massive time savings, sure, but it carried relatively few passengers and chugged an astonishing amount of fuel. Now, at the exact same time Concorde was being developed, wide-bodied jets like the Boeing 747 were taking over the skies. They were much slower, flying at subsonic speeds, but they carried hundreds of passengers and massive amounts of cargo. That made them dramatically more efficient per passenger. Airlines could sell way more seats. The operating economics of the 747 were an absolute goldmine, which made the time savings of the Concorde completely unjustifiable for most of the market. And the financial impacts just cascaded from there. Concorde couldn't simply fly its top speeds over land because the sonic booms were literally shattering windows below. That immediately eliminated dozens of commercially attractive routes. Plus, its high fuel consumption severely impacted its daily operating economics, especially as fuel prices began to spike in the 1970s. On top of that, environmental concerns meant there was massive pushback from people living near airports because of the extreme, deafening noise during takeoff. The business case was incredibly fragile. The technology had immense value and prestige, but the daily reality was that it was bleeding money.
The final act of the Concorde was undeniably tragic. After its spectacular debut in 1976, it kind of limped along as a prestige symbol for decades. But then, in the year 2000, Air France Flight 4590 crashed shortly after takeoff from Paris, tragically killing all 109 people aboard and 4 on the ground. Investigators found that debris on the runway had caused a catastrophic chain of events. The entire fleet was instantly grounded. And while safety modifications were made and it did eventually return to service, the world had fundamentally shifted. The September 11 attacks in 2001 created a massive shock for commercial aviation, drastically weakening passenger demand. Finally, bowing to those incredibly difficult economics, Concorde completed its final commercial flights in 2003.
So the crucial point is, we have to clearly define what happened here. Concorde was not a technological failure, it was an economic failure. The technology existed, it worked perfectly, and it safely carried passengers across oceans faster than sound. But a technology can work flawlessly, yet still fail entirely if the market cannot support its business model or operating costs at scale.
Part 4. The Billion-Dollar Lesson. Echoes and Modern Tech. Now, the story of the Concorde didn't actually die in 2003. The aircraft pushed forward materials science, engine tech, and aerodynamics so significantly that the dream of supersonic travel actually survived. In fact, companies today are seriously exploring supersonic passenger travel again. Why? Well, because we now have vastly better materials and much more efficient engines. Advanced aerodynamics and digital design allow us to simulate things perfectly before we ever build them. NASA's even heavily researching noise reduction technologies to soften that destructive sonic boom. The whole concept is becoming economically interesting again simply because these new technological improvements might actually solve the very financial problems that defeated the Concorde back in the 70s. But whether it's the return of supersonic jets or any massive new technological undertaking, we always have to pause and ask the most uncomfortable question in innovation. Does the world actually need this? Because the lessons of the Concorde map perfectly onto today's ambitious investments. Think about it. Companies are pouring billions into artificial intelligence, new energy systems, enormous data centers, rockets, and autonomous vehicles. The scale of investment is just staggering. But the unknowns are equally massive. Will AI be a transformative industry or a spectacular, incredibly expensive experiment? Will the economics of new energy become attractive enough? Can the market actually support these huge data centers at scale? Will the operating costs of autonomous fleets be acceptable? The difference between a world-changing industry and a historical footnote will very often come down to economics, not just engineering. Now, what's really interesting about this slide is it perfectly captures the ultimate paradox here. Concorde proved we could fly passengers faster than sound. It reached the future. It just couldn't make the future affordable. It reminds us that the future isn't simply what technology makes possible. The future is what technology makes possible at a price society is willing to pay. As we look at the billions being poured into modern tech today, we really have to ask ourselves, are we building the next 747 or are we just building the next Concorde? Thanks for joining me on this explainer. I really hope this leaves you looking at tomorrow's innovations in a whole new light.